In this section, we are going to talk about macros. We have used macros throughout this course, such as print line. So in this section, we are going to explore into macros a little bit more and see what a macro is and how it works, as well as create our own. Macros are essentially a way of writing code that writes other code, which is also known as metaprogramming. The best way to understand macros and how they work is to create one. So let's create a greatest common denominator macro. And to start off, we will just say macro rules, and it will give us a template for creating a macro. And now we will give our macro a name, and in this case it'll be GCD, which for us to call our macro, we just say GCD with the exclamation point. Now we are going to give two arguments for our macro, and an argument is prefaced with a $sign. So we'll call our argument 1, we'll just call it A, and it's going to be a token of type EXPR, which stands for expression, and then we'll do the same thing for our second expression. And now in here, we can start performing our logic for our greatest common denominator. So we'll say let mut m equals to our b parameter. Notice I did money b. And then we'll say let mut n is equal to money a. And now we'll execute our loop. So while m does not equal to 0, we'll say if m is less than n, let t equals m equal n, and then n equals t. And now we do m equals m mod n. And then after that loop is done executing, we just return n. And that's a basic algorithm for computing the GCD. So let's give our macro a test run, and I want to print it out. And so we know that the GCD of 14 and 15 is going to be 1. So by calling GCD macro here, what this does is it takes in 14 and 15 here respectively. So A will be 14 and B will be 15. And then it essentially just executes this code for us. So remember when I said it is a way of writing code that writes other code. So when we call GCD, or compile this macro I should say, and then run it, when we compile it, it's going to write this code into the binary for us, which is, as I said, metaprogramming. So if we run this, we expect 1 to be printed out, which is exactly what we got. And now if we just change it to 16, now we should have 2. So it looks like everything is working correctly. And so that's really all there is to it, to a macro. It's basically just creating a code that's going to write other code for us and allows us to reuse it in a much simpler manner, such as just saying GCD with an exclamation point. So I hope you enjoyed that quick little example on how to create a declarative macro. I hope you enjoyed this section on getting an understanding of how macros are created and how they work. We are now going to go over the solution for the assignment for this section. The question is, create a macro called op that takes 3 arguments. All 3 arguments will be integers, but the third argument is going to be how we tell the macro what operation to perform. Operation 1 is add, operation 2 is subtract, 3 is multiply, 4 is divide, and 5 is mod. So I went ahead and put all of the example outputs that we are looking for into main, so now that we can create our macro rule. So we start off by saying macro rules. We give it a name. In this case it is going to be op, and now we are going to specify the parameters that we want. So we will say A, B, and C, which is going to be how we specify what operation we want to perform on A and B. So now we can very easily just run a match block on all of these, and we will say 1 is going to return A plus B. Need to put that $sign. 2 is going to return A minus B. 3 is going to return A times B. 4 is going to return A divide by B. 5 is going to return the mod, A mod B, and then if any other value is passed in that is not 1, 2, 3, 4, or 5, we will just return -1 so that we know that we passed in some unexpected operation. So now if we run our macro, we expect to get the appropriate values of 7, 3, 10, 2, 1, and then -1. So I hope you enjoyed this assignment on creating your own custom macro that is going to allow you to specify what operation to run onto arbitrary values.